for our next speaker, a prominent member of our community. You probably are not seeing him for the first time. You're probably seeing him for third, fourth, or fifth time. He's been with us for a while, and I've personally had the pleasure of communicating with this person a lot, and trust me, he's very, very knowledgeable about Zabbix, and you have a lot to learn from him. So don't be afraid to use the Q&A section and ask him some questions, and maybe network with him in Telegram, or he will probably be readily available for discussion. So the next speaker, CEO of IntelliTrend Germany, Wolfgang Alper, he's going to talk about IoT, specifically MQTT protocols and Modbus, and how you can use those to integrate Zabbix with some external hardware. So let's welcome Wolfgang Alper.
Hello and very welcome. My name is Wolfgang Alper, and today I would like to share with you the talk, Let Me Subscribe Zabbix Master's IoT topic. Well, in version 5.2, Zabbix added support for two very important protocols that are being used in the world of the Internet of Things. And there's the MQTT protocol and the Modbus protocol. And in this talk, I would like to dive a little bit deeper into MQTT and see how we can benefit from Zabbix and this latest edition in Zabbix when integrating Zabbix in the world of IoT or the world of IoT into our Zabbix network monitoring. So the question is, what is MQTT? What is the story about MQTT? And let's have a look at the basics. MQTT is the abbreviation for Message Queuing and Telemetry Transport Protocol. It was invented in 1999, designed to be bandwidth efficient, lightweight, battery efficient, and a friend of mine told me it was also initially developed to allow monitoring oil pipelines. It's a well-defined ISO standard, and these days it's really rapidly increasing adoption because of its suitability. So it's being used in the Internet of Things environment, in machine-to-machine communication, in mobile applications, and so forth. Usually it uses the TCP/IP protocol, the well-known TCP/IP protocol, as a transport protocol. And for that, it uses the default port, which is 1883. And also MQTT can be encrypted using TLS transport mechanism. And in this case, the default port would be 8883. There's a variation of MQTT available, which is called MQTT SN or MQTT for sensor networks. And really, this is being used for non-TCP/IP networks, like, for example, Zigbee, like UDP or Bluetooth. And MQTT itself uses, and that is really important to understand, uses a mechanism which is based on the publish and subscribe pattern. And we will look into this in a minute. There are actually two types of network entities available, message broker and clients. Also, MQTT supports 3 levels for quality of service. And these levels are level 0, which I call fire and forget. And fire and forget means simply you might get the message, you might receive the message, or you will not receive the message. So it's as simple as that. So there's no guarantee in delivery. Then we have quality of service level number 1. And I call it like at least once, which means you will get a delivery for the message, but it might be that you get the same message twice or multiple times. So your application needs to be really prepared about those duplicates. And last but not least, there's a quality of service level number 2, which means exactly one. So you get for your subscription exactly one message, which is great. And it's also then the slowest service available. So what is this public subscribe thing about? So what does it mean? And have a look on the slide here. So in the middle, we have our MQTT message broker. And the MQTT message broker consumes messages that are published by clients on the left-hand side. So client number 1 and client number 2 actually publishing data to the message broker using so-called topics. In our example, that is office temp or office humidity or office indoor air quality. You see the names. And these topics they look a little bit like URLs on the web page. And these, for example, would be a two-level topic. So we have two levels there, the level office and then the level temperature. And data is carried and addressed and sent to these topics. On the right-hand side, you see client number 3 and client number 4. These are our subscribers. So they tell the broker, hey, I'm interested in if something is published on that particular topic. That's what they do. So they are some sort of listening to the temperature in our office or the humidity value in our office. And every time a client on the left-hand side is publishing a message to the broker then notifies all of the subscribers, in our case, client number 3 and 4, and then they get the value. So that's the basic idea about publishing and subscribing in MQTT. Now, a client cannot only subscribe or publish data. In fact, a client can be a subscriber and a publisher at the same time. And have a look at the example here. So on the left-hand side, you see client number 1 who's publishing a brightness value, and client number 3 has a subscription for that brightness value. Now, let's say that our client number 3 is a smart client, has some intelligence, and our smart client figures out that the brightness of 1500 as a value here might be too low. So it decides to publish a new message to the topic Office Light Controller with a payload increase to let the light controller know that it should increase the brightness. And client number 2 in our case would be the light controller itself. So it has a subscription for light controller, and then it will receive the message and maybe change the light, the brightness. So that's the idea. So we have a combination of both here. Also, you should know something, you should know wildcards in MQTT. So wildcards are pretty easy. So you have a substitute, you can say, for example, office plus brightness. So, and the plus sign can be then substituted by any name you like for your topic. And because the plus sign substitutes just one level in our topic, it's a single level wildcard. While the pound sign, for example, is a multi-level wildcard. So you see an example in client number 4. Office kitchen /pound means anything that is being sent to Office Kitchen will be consumed by this client. So in this case, it will receive the data for Office Kitchen brightness and Office Kitchen temperature, for example. So to sum up what we have seen so far, clients can publish and subscribe to one or more topics at the same time. One client can publish and subscribe at the same time, and clients can subscribe using multi and single level wildcards. Also, clients can choose between different quality of service levels. There are also advanced features, of course, in MQTT, and I don't want to dig into that because of time constraints here, but you should have heard about them. So, for example, messages can be retained on the brokers for new subscribers. That means that if a new client subscribes to a particular topic, then a publisher can mark its messages as retained. So a new subscriber will get the last retained message, although it's not just published. Also, clients can provide what is called the last will and testament. And that means upfront, on their initial connection, they can send a message to the broker using a particular topic and say, please broker, in case my connection dies for whatever reason and I have subscribers, please send my last will and testament message to those subscribers. So these are really useful features of MQTT, but we won't cover them here. So you might ask yourself now, Wolfgang, we spoke a lot about MQTT. Where does Zabbix come into play? So let's take a real-world example of how we can integrate Zabbix into the mix. Here we see on the left-hand side 4 sensors: server room, training room, sales room, support room. And you see 4 different topics: Office, Bielefeld, server room, Office, Bielefeld, training room. So Office is clear. Bielefeld is our hometown here. So these are the sensors in our office in Bielefeld. In the middle, we have our Mosquitto MQTT message broker. Mosquitto is one of the famous, well-known message brokers. So if you need a starting point, that might be your choice as well. So our sensors are actually publishing the data to the Mosquitto message broker. And from there, any MQTT-enabled device or system can pick up those values. In our case, it's the home automation system. So the home automation system subscribes to our message broker and then has access to all of the values that are being provided by our sensors. Because of this latest addition in Zabbix 5.2, the MQTT support and the Modbus support, but here we're looking for MQTT. Also, Zabbix can now subscribe to our Mosquitto broker and immediately gets access to all of the sensors that are publishing their values to the broker. So Zabbix doesn't really need to know anything special. It's just subscribing to the broker. And the sensors, they don't need to understand what is Zabbix because they're just publishing their values as they did before. We have seen in the previous slide that we can have multiple subscribers. So we have seen that multiple clients can actually subscribe to one topic on the broker, and we can use the same technique here. So in our case, the home automation system can subscribe to the message broker as well as can Zabbix subscribe to the message broker, both retrieving the same values if they are interested in. So that's really a cool feature of MQTT and it's built into the protocol. So there's nothing special required to make this setup work. When you really work with MQTT, sooner or later you will get a notice about an application which is called Node-RED. And so we put Node-RED here to the mix itself. And basically Node-RED is some sort of flow-based programming tool. So it allows you to subscribe to a broker, to publish messages to a broker, so it really acts as a client, but it can also do some transformation in data, so it can work with the data. And we will see that in the upcoming slides. Now, having this setup, it would be great if, for example, our Zabbix trigger could fire. I mean, they can fire, of course, yeah, but it would be great if they can fire and can pass information over to our MQTT setup. So they can actually publish the outcome of a trigger to the broker, and then this outcome might be picked up by, for example, our home automation system. And we will look into this as well. So last but not least, I would like to mention that, of course, you can have two different Zabbix instances subscribing to the same broker, because from the broker point of view, these are just different clients. So what is Node-RED about? Node-RED is a construction kit for the Internet of Things and home automation. And it really acts as a client, so it can publish, it can subscribe, and it's a flow-based tool. Technically, it's based on Node.js, and to get access to this cool tool, you just need a web browser. So you install the application, and then you open a web browser and connect to it, and you are set. It supports input nodes, output nodes. It supports some processing nodes. And it can be extended easily with plugins and with custom function nodes. So this slide here gives you actually an idea about how the Node-RED interface looks like and why we're talking about nodes here. On the left-hand side, you see different node types, and in the middle you see the workspace where some of those nodes are connected together. And the left-hand side, for example, shows subscription node. So in this case, Node-RED is subscribing to a topic, and when it gets data from that topic, so when the broker passes data that has been published by someone else, then the yellow function nodes can do some data transformation, for example, with that data. And then there are some other nodes like the brown one, where we, for example, just write something to a log file. So that's the basic idea of how Node-RED looks like and of what the idea behind those nodes is. Coming back to our real-world example, to our sensor setup, let's have a look into the data that we get actually from our sensors. So you see that we get a raw JSON string, and this JSON string contains a lot of metrics. I would say between 20, 30 metrics are delivered in a payload. And you see the parsed JSON object in the Node-RED debug node here. So we see our temperature, we see the humidity, we see Wi-Fi quality, we see indoor air quality, and so on. So the question now is, how can we actually split the data and work with the data? And I would like to see, I would like to mention that we can either split the data on the MQTT level, which means we are using Node-RED to extract data from that entire payload and then publish that particular metric on its own topic. There would be one way to go, and it would be a good way to go if we have, for example, let's take our light controller back. So maybe our light controller just understands brightness and nothing else. So in this case, we would like to pass forward maybe the brightness, or maybe just how it should increase or decrease the light. That would be an example for that. And we can also work on the Zabbix level. And on the Zabbix level, things are much easier because of the recent additions that Zabbix made in terms of pre-processing and dependent items. So what we can do is we actually can set up our MQTT item as some sort of master item and then use dependent items together with pre-processing to extract the data out of it where we're interested in. We can also use a combination of both methods. So for example, if you have this particular light controller, then we extract data for the light controller. And other than that, Zabbix keeps the entire payload and does a pre-processing and dependent item thing. So here we can see how we would split the data on the MQTT level using Node-RED. On the left-hand side, you see the node setup. So we have our subscription node, we have our data processing nodes in the middle, the yellow ones. I took the temperature as an example here. And you can see that we are using just JSON processing in the temperature node to extract the temperature as a metric and then to republish it under its own topic. In this case, we take the original topic and just append /temp to it to create the new topic name. And on the right-hand side of the slide, you see that in the debug node that we just get a new value, just one single value for this particular new temperature topic. So that is how we can split the data in Node-RED, for example. So how does the Zabbix side of things work to do something similar? And first of all, we need to get the data. And we get the data with this brand new MQTT get item provided by Zabbix in Zabbix version 5.2. And it's based on the Agent 2, so it requires Agent 2 to be installed. And also it requires to be set up as an active check. And that makes pretty much sense because what we do is we subscribe to the broker. So what happens is that every time some client publishes a message to the topic we are interested in, the broker will push that data to us. So we need to be prepared. So that's why we need an active check. So MQTT get must listen to the subscription and to get notified when the new data comes in. What else do we need? The broker URL, so which broker we are going to connect to, and the topic name, and maybe also we are looking for the username and password thing. One thing might be important to mention, and that is, so let's say we have our 4 sensors. We have our sales room sensor, server room sensor, support room sensor, and the training room sensor. And let's say we would like to build 4 hosts in Zabbix: sales room, server room, support room, training room, for example, to collect the data there. So in this case, the question is, how can we do the setup? How many agents would we need? In a traditional Zabbix, we would need 4 different agents to do that, because each agent running as agent active would have to configure its host name. So that would be the host name where it will send the data to, and that's it. And that won't work for our setup here in a cool way, because we would like to have just one agent installed and then handle maybe different hosts by subscribing to multiple topics. So that is where this feature request that has been implemented in Zabbix 5.2 as well where this feature request comes into play. So running an active agent checks for multiple Zabbix hosts at the same time. So what we can do is we set up our hosts in Zabbix as usual. We define our MQTT items as usual, but then we set up just one agent with more than one host name. In fact, with all of the host names that agent should be responsible for. So in our case, that would be the 4 host names of the hosts in Zabbix that refer to our sales room, server room, and so forth. So in summary, we can say with this nice addition that's being implemented in Zabbix 5.2, we have the ability to run one Zabbix agent in active mode, but can still provide data to multiple hosts in Zabbix. So it's a really, really great addition, and it works very well with this enhancement tool or with the new features of MQTT in Zabbix. So the rest is pretty much straightforward. So we have a master item, which is our MQTT get item. Then we define several dependent items. And for each dependent item, we define our preprocessing. And then we do the preprocessing thing with JSON preprocessor in this case, extract the values, and we are set. So have a look here, please. This is how the master item and all of the dependent items look like. And remember, every time the master item gets an update, also get all of the dependent items an update, which is built-in functionality in Zabbix. Because everyone loves graphs and dashboards, we added this here to the slide. So yeah, so these are the metrics from our sensors. Nothing special, but keep in mind the data received here. Everything is based on the MQTT item and the payload in the MQTT messages received from the broker. So you remember there was a statement from me that would be great that if Zabbix could itself notify MQTT environments or MQTT-based environments, for example, that a trigger fired because a threshold might be exceeded somehow. So the question is, how can we do this? Now, it's pretty simple. What we do is we define a new media type. We're using the command line tool from Mosquitto, which is Mosquitto Pub, that allows us to publish a message. And this way we have a new media type in Zabbix, and then we can send and use this media pipe to pass data over to our message broker. Of course, we need to make sure that the data being sent to the broker has a right format. In this case, we are using JSON as a transport format for this. And you see we define our JSON problem template and the JSON problem recovery template. So we have message, we can support both of those message types. And that's how it looks in Zabbix. We have our problem view. You see there is a problem. You see the action has stepped in, and the message, the media type fired using the subscription, and then the debug node of Node-RED, we see that we received the data from Zabbix. So perfectly fine. You can use this technique together with Node-RED to do a sophisticated setup. So you can take the data from Zabbix, forward it by actions and media types, and you can pre-process them on top in Node-RED, and then you can do many different transformations to work with that. So it's really a flexible design. Well, we had we really were really excited. So we were really excited when trying out this new stuff in Zabbix 5.2 beta. And if you are interested in as well to see how this MQTT stuff works and how Zabbix can support you there, we set up a GitHub account. And on this GitHub account, you will find all information necessary to access a live broker that we made available to you. So you can use our live broker, which gets data from our sensors every 10 minutes. And on this account, you will find templates and access data and the address of the broker, etc. So everything you need to get going. So if you're interested in, you might want to give it a try. Yeah. So I hope you enjoyed this talk, and I hope to see you next time. Thank you very much. Bye.
Thank you, Wolfgang. That was really nice technical talk. And now it's time for questions and answers. So, Wolfgang, are you ready? How are you doing?
Hello, and thank you so much. Yeah, I'm actually ready, and yeah, it it was great fun preparing this talk because of this this cool feature being added. Yes.
Yeah, it's
So,
always nice to see your speeches. Like we can tell that you're really excited about like new features that Zabbix brings in, and you know how to properly utilize and use them. So it's really great hearing from you. So now time for some questions. So let's see, we have a couple. So if the MQTT client gets overloaded due to high message frequency on subscribed topics, how will that affect Zabbix? Will it affect Zabbix at all?
do you mean I try to understand the question. So it might be that the broker is being overloaded, or it could be that, for example, the broker is capable to pass messages, but the question is referring to the Zabbix agent, that the Zabbix agent is not able to follow up. I don't
think
know
the
what
question is about the broker. It's just my guess, but going by how it's formulated, I think it's more about the broker.
Yeah, I would say I haven't encountered this yet, so it didn't happen to me. I haven't encountered this, but I would think that there are quality of service levels defined in the MQTT protocol, as I mentioned on the first slides, and there's a QoS level number 2, which guarantees delivery. So in this case, if number 2 is being used as a quality of service level, then I would expect that messages won't get lost, but would get resent in terms of failure.
So they would get resent. All right. So next up, a very general question about IoT. So maybe you can then indulge us. So a question is, so does that mean can I monitor even my own fridge or even Amazon Alexa? And going from that, I will just kind of elaborate. And so maybe you can kind of tell us what else would you expect from the IoT side of things? Like what else would you wish, what kind of protocols or things would get added so we would truly cover everything? Or is the situation right now, is it sufficient? No wishes for the future, it's perfect as is.
Great question. I mean, there's always room for improvement, and certainly there can be done a lot of things and adding protocols. But I think really that the native support, and the point here is it's native. It's native support, so you don't need any third-party tools. I mean, you can use custom scripts. You can do anything to enhance Zabbix, as we could do with the first version of Zabbix. So user script parameters was an excellent design decision from my perspective. So you can do it. But I think really that the official support of MQTT is a quantum leap for Zabbix, because it opens the door to any or to most, not any, but to most IoT infrastructure. So to give you an example, we have a customer. We have more than one customer, but we have a customer, and this customer has infrastructure monitoring. And what I mean by that is not IT infrastructure, so no switches, no server, but I mean things like electricity generators, production systems, so this big machine stuff, and they have their own monitoring provided by the vendors of those infrastructure in place. And then the question came up, so how can we actually integrate maybe alerts or maybe some metrics from this infrastructure monitoring into Zabbix? And really the protocol being used for the infrastructure monitor was, by the way, was MQTT. So they were using this MQTT protocol. So what we did is we made it using external scripts and MQTT support. So just to give an example. So I think that MQTT is really the most important IoT protocol so far from my perspective. And because of this, I think that is the big step forward in Zabbix.
Yeah, thank you a lot, Wolfgang. And from my side, I can say that I think most of us over here in Zabbix will be expecting your contributions in forums, on GitHub, in your projects, and so on. It's always a real pleasure, like seeing how you implement things, and that actually teaches us a thing or two. So yeah, thank you a lot.
Thank you very much.
Thank you, and see you around.